Hello and welcome to another Solana tutorial. Today I'm gonna combine two of my favorite topics, which is security and the new token program. And we're gonna talk about immutable owners. Yeah, there's an immutable owner extension, and today I want to have a look at what that does, what it's useful for, and what the implications are if we don't have that. Like with the old token program, Token CAC does not support immutable owners, and that's an issue. So actually I'm gonna start there probably, because that is the reason why I looked into this in the first place. Actually, immutable owners are probably the most underrated feature of token extensions, because it's just like, yeah, whatever. It's just an immutable owner, right? So what, right? Nobody cares, right? It's just, you know, whatever. Nobody thinks about that. But actually, you should be thinking about that. That it's so important that we have that, and you want to use it. And why? Well, watch this 1 hour video of me talking about random stuff to get to the conclusion that is just important for security reasons. Could have told you in the very beginning. Yeah, now I did. Haha, hello, and welcome to this Solana tutorial where we talk about token extensions, immutable owner. All right, yeah, let's do it. I need a wallet owner. I'm spending too much time on this. We're gonna use the owner. Cool. So, can I get an airdrop? Yes, I can. Wonderful. DevNet seems to be working. Isn't that great? Before we can actually work with a token, we need to create a token. Toady. Create token. Toady. Okay, let the mint be this. And then, before we can transfer some stuff, we gotta have to create associated token account. So, my key pair will pay. The owner, I'll create it for myself, so also for the key pair. That's the mint. So we need to first... sorry, I'm too much in Rust lately. I constantly forget that constants in TypeScript are with const and not with let. Not confusing at all. So anyway, the ATA we get from get associated token from the mint and the owner. There we go. So we get the ATA, put it in here, create that, and then we just put that in a transaction. We're gonna use a regular transaction because that's the way how I know it. And eventually we're gonna get the new Web3.js, and then all of that is gonna change anyway. So I'm just gonna then learn the new way. And we add that instruction. And then all I want to do for now is simulate that transaction. It's deprecated, step up, but I don't want to use a version transaction because I don't know how to do it by heart, and I can't be bothered because this is not the topic of today. Focus. So if I now, actually, why did I call it transfer? I'm not doing any transfer yet. Whatever. If I now run that script, I get nothing. That is absolutely true because I did not await the simulation result, and I also certainly did not print it. But when we do that, then we get the following. Check this out. Now, the associated token program is called with a create instruction, which then calls the token program to get the account data size. This is already the first part where the token program is called for kind of backward compatibility, or actually forward compatibility reasons, because for the token CAC, this should always give the same size. In fact, let's check it out. GitHub. Somewhere in here we have token program. So that's the token CAC source, probably the processor, and somewhere in here should be a get account data size. So what does that actually do? Unpacks the mint. It just checks if it's a valid mint, and then it returns the account length to bytes. And that is actually a constant for this program. Account length in bytes, there we have it, 165. For token CAC, this is a constant. We would not really need to call that because we know it's always that. Plus that program is immutable. But For being forward compatible, we do call that instruction, because that makes it so that the associated token program, that thing, we can hand any token program and it will just always call that to figure out what the size is. Because for the new token program, token 2022, token extensions, this might get you a different size depending on the extensions that are activated for that token mint. So there it makes sense to call that instruction. If I create a new token account with the token keg, then I don't really need to call that. But we do anyway, because forward compatible. We want to treat all the token programs themselves. So that's why basically I'm imagining they added this instruction to the token program just so we can do the, and you know, it's not like, you know, whatever. Yeah, and that basically returns that constant, returns the data. So this actually, if we decode that, should be 165. What's A5? A is 10, 10 times 16 is 160 plus 5 is 165. Yeah, there we have it. Boom. Anyhow, token program returns 165, ends with success. Then the system program is called to actually create that account with that size. And then, and now it gets interesting again, we initialize the associated token account with the token program. And here it gets interesting. Before we actually call the token program here with the initialize account 3, because that's essentially the initializing the account. If I just initialize a token account from a regular account that I created earlier, I just need to call this one, this initialize account with 3. But there's another step in between where the token program is called again, and it is calling the initialize immutable owner. And here's the interesting thing, because this thing doesn't do anything for the token program, like for token keg. Remember in the last video, and this is actually the reason why I started looking into this, why do we get that weird log message, right? Why does it always say, please upgrade to SPL token 2022 for immutable owner support? I was like, that's a useless log that we have in there that we could have really saved ourselves, right? Because now we always log that. It's one of the previous videos, this one, I basically complained about that. But then I thought about why we actually need that, or what that actually does, or when is that actually printed. Well, it's printed when we call the initialize immutable owner on token keg, which it doesn't support, hence the message. And actually we can also have a look at what the initialize immutable owner does. I'm assuming it's literally just printing that message, and that's it. Let's see, do we have initialize immutable owner? So what does it do? Gets the account info, unpacks, borrows the data, checks if the account is initialized already. Then it says it's already in use. See, because we call this before we initialize the token account. That's why it's called before. If after initializing, the state is initialized, and then this will fail. But this doesn't fail, and it just gives me that message. That's literally all that does for the token keg, because it doesn't support immutable owners. The regular token program does not support immutable owners. But the associated token program would love the token account to be with the immutable owner. That's why it's calling that instruction. Because for an ATA, it makes perfect sense that the owner should not be mutable. Okay. Andy, you've been talking a lot about immutable owner and stuff. Can you explain to me what that actually is? Of course I can. Yes, gladly I'll explain what immutable owner is. As the name suggests, it's immutable in the sense of cannot be changed. Owner in the sense of the person owning the token account, aka having the authority over the token account. I keep complaining about the naming being a bit weird with the owner, because there's the owner of the account, which is in this case the token program, and then there's the owner field inside the data of the account, which is the authority wallet that can, you know, transfer and burn tokens from this token account. Anyway, they called it owner, so we call it owner. And yeah, the immutable owner functionality essentially just means that the token account owner cannot be changed. Now, why is that a problem? Or why do we want that? let me introduce you to one, unfortunately, very common attack that attackers love to play on people. And that is stealing their token accounts, especially ATAs. Actually, let's do it. Let's play the attacker. Let's actually create that token account because, I mean, after not being able to make it immutable, we can initialize it and then we do have success on the associated token program as well. So here success on this level and then here success on this level. That number, by the way, is the CPI depth. 1, then we go on 2, and then we have success, so we are on 1 again, then we have 2, then we have success on 1 again, then we have 2, until we have success and we're 1 again, then 2, and then we have success and we're 1 again, and then we have success and then are done. Does that make any sense? No, whatever. Let's actually send this, not just simulate, but send and confirm a transaction. Maybe I want to await this, but now probably it comes back with the yeah, provided owner is not allowed because I already created it. Trust me on that, it worked. I have an ATA. Cool. Let's play attacker. In the easiest case, the attacker just stole the private key. Somehow the private key got leaked or the seed phrase got leaked, and so they have access to the actual key pair. That's the easiest way, but the same also works by making them sign a transaction that does that. In our case, let's say we have access to the private key, because then it's super simple. All we got to do, the ATA is already created, and now basically we create, what is it called? An authorize? Set authority instruction. See, there you say it's set authority. There you use the right word of authority. It's not set owner instruction, it's set authority. Okay, let's set authority. For that ATA, with a current authority of me, because there are different types, of course, I could set the close authority, the freeze authority, although that's on the token mint, not on the ATA, but the close authority and the account owner, those are on the ATA or on the token account. And the ATA associated token account is a token account. So I change the owner and I say the new authority is the attacker. Simple as that. Steal ATA. But like this, actually I just simulate for once. Steal. It's just a set authority instruction. That's all it is. That's all it does. Can I get the ATA real quick? There. Solana FM, your favorite Solana radio. Oh, that's bright. Man. This account is initialized. It is a token account. There are no tokens in there, but that's fine. Where do I see the owner? Oh, there. Owner. This is the owner. For some reason, I still prefer to look at explorer.solana.com. The good old vanilla explorer. So that's the address itself. That's the mint that's stored in the token account. And that's the owner that's stored in the token account. If you wanted to go even more low level, you could say Solana account, give me this. And then you could decode that somewhere in here, I think. No, first is the mint state. Then probably is the mint. And then probably is the... Wait, what am I doing wrong now? Where's the initial... I know the source code. So first is just the mint, then is the owner, then the amount, and the state only comes after, actually. Okay, interesting. So this is the mint, this is the owner, and there is the state, which is initialized. Because really we only have 2 states here. No, we have more states. There's also frozen. Okay, so I have 3 states. Okay, 0 for uninitialized, 1 for initialized, and 2 for frozen. Okay, anyway, we're not deep diving on the token program, but it's always nice to have a look at that as well on like the raw stuff, because we are dev self-taught. We want to understand how that works. I mean, it's nice to be able to look at it easily on an Explorer, but that's the one thing that makes a Solana dev, that they understand this sort of stuff. Anyway, we also want to understand how easy it is to freaking steal a token account. Too easy. Look at that. I just sent that transaction. I mean, granted, I need to have a signature from my victim wallet, but that's not too difficult to get. just pretend to do an airdrop of something and people are gladly signing anything you provide them. And boom, gone is their token account. Check this out. Actually, I don't even need to check this out. I can just refresh here. Check this out. Now suddenly my poor little token account is owned by the attacker. What? And this is annoying because obviously I cannot spend balance from that account anymore because I don't own it. The attacker can. And also it's especially annoying because that was an ATA, meaning this address was derived using the associated token program. If you want to send tokens to me, right, to that owner address, that previous owner that we had here, which again also we don't have anymore, gone it is. If you wanted to send tokens to me, you always send it to the associated token account. That's the default on Solana. And if an attacker claimed your associated token account, then if somebody else sends you tokens, they end up in the attacker's account. So in the attacker's wallet, you can say, because Solana just operates on accounts. And the one being able to sign for the authority of an account, aka the owner of the account, is able to claim the balance. And that's a very common hack or like exploit or like attack that happens to way too many people. To some it happens in the way of, yeah, they signed one malicious transaction and then a bunch of tokens account got claimed. Like usually they always take USDC and whatever else is the hot mint right now. Like I got a lot of parcel and wormhole token accounts being stolen because that's where the airdrops happen. And so if you go claim your airdrop, you claim it thinking that it's going in your wallet, but actually goes to the attacker's token account because it used to be your ATA, but it's not anymore because the attacker freaking stole it. And that's the issue. So, oh wow, I just realized that I have like this one guy, what is it called? The Rayman. Only on one hand, but like I have Rayman hands. Woo! Anyway, I'm having too much fun with green screen. I like this hoodie though as well. I love this New Dime Andy. In case you forgot what my name is. New Dime, by the way, doing good stuff in terms of security, and that is one of the which is one of my favorite topics. That's why we're talking about this today. God damn, I don't like token accounts being stolen. I like, it's annoying. So it would be really amazing if we could just say, hey, please never change the owner of this token account. And that's what the Immutable Owner extension does. Unfortunately, for token keg, it's not supported, but the associated token program tried to make it immutable because an associated token account should really be immutable because it's derived with the owner. So there should really never be a different owner than the actual owner that the account was derived with. If Token Keg would also support that, then a bunch of users would still have their funds. But they don't. They got stolen. And it's pretty annoying to see. Since I'm developing this Solana asset recovery tool, this is one of the issues. If an attacker has claimed the associated token account, in some cases you can't do anything because the program expects the ATA, but the ATA is not even owned by you anymore and you can't specify anything else, and then you're screwed. So yeah, that's super annoying. I freaking hate it. But yeah, the old token program does not support it. However, when the people from Solana Labs, now Ansa, or should I say one person, John Cinque, developed the new token program, they took that into account and they actually implemented a feature that allows you to set an immutable owner. And today I want to have a look at that because I actually never had a look at that. Because it's like, yeah, whatever, immutable owner, whatever. I mean, who cares if you can change it? I care, god damn it, and you should care, because if it can be changed, then an attacker will change it if they get the chance to. So if it was not possible, that would already, you know, make it much safer. And let's say in 99% of the cases, you do not want your token account to ever change the owner. Because in most cases, you just transfer out the tokens anyway. You never really move the token account because in most cases, you want the tokens to be in the ATA anyway. There are some use cases, of course, where token accounts are moved around and the owners are changed, especially when it comes to working with programs. But for most of the token accounts, and especially ATAs, you don't want the owner to change. So for most token accounts, I would recommend that you initialize them with Immutable Owner. Let's do it. Let's do it. Let's do that. 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 Create ATA with immutable owner. Okay, so this mint we have already used. We need a new one. And yes, I'm gonna grind myself another one. Cause I want my vanity address. To7. Create token. Wait, hold on. How do I specify the program? Something program ID. Program ID, yeah. Or -p. We want to create it for the token. Here it's still called token 2022. Doobie-dee-be-doo. Token Z. Cool, that worked. So we use this mint. And it's pretty much all gonna be the same because this instruction will then call the immutable owner thingy thing. So yeah, let's go simulate that. Oh, yeah, okay, my bad. That's true, we do need to change some stuff. And that is, we need to get the associated token account for the right program ID, which is the token 2022 program ID. And then also when we create the associated token account instruction, we also need to tell it that this is the program ID it's supposed to use. The associated token program is the same for both of them, so I don't need to specify that, but the token program is different. So with that different token program, there we go, that looks much better. It looks pretty much the same, except that now the token Z is called and not the token keg. Again, with get account data size, we do get a little bit different values here. So apparently this one is a bit bigger, I guess. Is it? AA, yeah, so it's 170 bytes, so 5 bytes more. Yeah, I can read hex. Are you impressed? Same thing, we create the account with the system program. We initialize the associated token account, and that means initializing with immutable owner and then initializing the account. And then we get success. So actually, what do we want to do first? Look at what that does or see if it worked? Let's look what it does, because I want to see what the initialize immutable owner does for the new token program. So again, in processor, probably initialize immutable owner. It's not too difficult. Look at that. It gets the account info. We unpack that. We initialize an extension, immutable owner, and set it to true. Extension, immutable owner. Not too big of a file, so it just has the type. And then in the set authority at the account owner, if get extension immutable owner is okay, so if it has that extension set, then we throw an error. And that's all the protection. It just checks if that extension is set. And non-transferable requires the owner to be immutable. Yeah, but basically what we do is we just init this extension. Let's do it. Let's actually do it. Let's actually send it and create that associated token account with immutable owner, because obviously per default an ATA is with immutable owner, but it depends on the token program if it's supported or not. Can I has a signature? Thank you very much. Basically what we saw in the simulation as well. Initialize immutable owner, that's the account. So the instruction basically just takes that one account, and here we see the owner, and that's the mint. And immutable owner is enabled. Amazing. So can I see this on chain? Yes, I can, but how can I see this on chain? Let's check that account. So again, we have the mint and we have the owner. The mint starts with the same first byte because also this one starts with TO, the public key. Anyway, so yeah, that's the thing. And then here it's initialized, and then somewhere behind all of that, there is a 02 and a 07. One of them tells us that it's an immutable owner, because those are the extension. Actually, maybe it's just that one extension. It's just the 02 is the extension, and then this is the data for the extension or something. Could be, I have no idea. I should look at that. But yeah, we also see, compared to the previous account, we have those 5 bytes more. See, here it ends, and here we have that much more for the extension. It's implemented a bit complicated because there's not like one byte exactly that checks if it's an immutable owner. It could be anywhere in the extensions depending on which extensions you have activated. So yeah, it would be really interesting to see what happens after only this instruction with initialize immutable owner, how the account looks then. Let's have a look at that, because I want to find out, because that's the way how we learn, by just playing around with it and finding stuff out, I guess. So let's do the things that associated token program does for us, except we do it manually. We're not gonna create the ATA, we're gonna create a token account. Any random address, we can make it a token account. So do we just take the 170 because we know it's gonna be 170, or do we try to query the size? I guess as an exercise, we can totally do that. I mean, it has a get minimum balance for rent exemption with extensions even. And yeah, the get account length. So the get account length is what we should call, because essentially this is implemented off chain, like the same logic that this has to return us the value is in there. With no extensions, it's the base size, which is account layout.span. So then there is an account type size, which is 1. So that's probably the 2 that we're seeing. That gives me the type of the account. So what type of account it is, which kind of makes sense such that we can distinguish between mint and token accounts. With the old one, we don't need that because we can do that by size. But yeah, it is. Look, uninitialized mint or account. Mint is 1, account is 2. That's why it's a 2. So we already explained what this 2 is. There. Nice. So yeah, that's 1 byte. And then extension types. Let's see, immutable owner here. For extension type immutable owner, we would add the immutable owner size, which is, let me guess, 4. The span of this layout, and this layout has an immutable owner, and the immutable owner is, well, it's an empty array. An empty array. Let me print that real quick. 0. Yeah, actually that makes more sense, that the immutable owner size would be 0. Okay, so that's 0. So the length for that type is 0, but still the length itself is 0, but then add type and length to length. What does that do? That is the length plus the type size plus the length size. So we have 2 more bytes for the type and 2 more bytes for the length. Okay, I'm starting to understand how Token 2022 serializes the extensions. It also adds the length and the type. Probably the type first and then the length. So for our account, that means here, that's the type of account of the token program. 2 is for it's a token account. And then this is the type of the extension. And then this is the length of the extension. So 0 more bytes are reserved for this extension. That's why 0. Yeah, and that explains those 4 bytes. Cool. Now we learned that as well. Nice. We know what that means and we know what that means. So the immutable owner extension is apparently extension number 7, or at least that's the identifier, the type. We would probably be able to count 1, 2, 3, 4, 5, 6, 7 and immutable owner. Here it is. Yeah. Cool. Yeah, you need to bump it up. We skipped those 2. Funny. Anyway, looks good. Yeah, okay, so we understand this. That's cool. Now coming back to, we want to just create a new token account so we can get the length, account length for extension type immutable owner. So that thing has 4 bytes plus 1 more byte because it stores the type of the account, which adds the 5 bytes. Nice. So that should be 170. Just to make sure it actually is. There we go, 170. Now we create that account. I mean, I can use the get minimum balance for rent exemption with, just for fun. Let's use this one. Again, that will just get me the size that I already got up here. So yeah, whatever. And the space that is account size that we just got from this nice little function here. So that's the create account instruction. And after we created an account, we can initialize immutable owner instruction, which takes the account and the program ID. That's it. So account and token program 2022. Boom. And then we put those two into a transaction and let's simulate, see how far we get. Do we get success? We do get success. We can create that account and we can initialize immutable owner. Let's do it. But also I would like to get the address of that account because it's just a random key pair. And then we're gonna send it. Oh, that did not go. Oh yeah, of course we're missing a signature of the TA because for the system program to be able to create it, it needs the signature. And there we have it. So this account, the 5Q no, is now my token account. Let's see what the Explorer would show here. It says it's an account owned by the token program. It has the correct amount of lamperts for 170 bytes, but that's all it says. What would you say? It says immutable owner extension, so that's already cool. Hehe. Extension length 0. Hehe. So what I would expect to see on chain now is basically an empty account because it hasn't been initialized. Just the extension has been added. So I would just expect the 02 and the 07 to be set, or maybe even just the 07. No, actually the 02 I would also expect to be set. And no, it's just the 07. That's all it did. It just initialized this extension with this type and this length, and that's all it did. Could it now make it a mint? Probably not. It probably checks that. I don't even want to try. But yeah, if I then initialize the account, then it will also write the mint and the owner and the initialized and the probably the type as well here. Or wait, no, here. Okay, cool. That's the immutable owner extension. Analyzed on a technical level, like on a how are the bytes serialized. But now to the interesting part of, well, does that actually work? And for that, we're gonna attempt to steal the ATA again. And let's try to steal the ATA that was created for this token. This token, yeah, with the attacker. So we provide the token program here and then create set authority instruction also for this token program. And let's see, steal with emo. The owner authority cannot be changed. Nice. 0x22. The owner authority cannot be changed because it is, guess what? Immutable. We have an immutable owner. The attacker is fucked in that case. They cannot just steal our ATA. Isn't that amazing? I wish all of our ATAs would be immutable, but they're not. Just with a new token program. And it's great that the token program, like the associated token program, sets them to be immutable per default. So at least that attack vector is closed for token extensions. However, with the old token program, we still get that issue. And the problem is most of the tokens are still from the old token program. So that's why this is still an issue. And yeah, some people might now be like, don't tell the attackers how they can easily steal our stuff. Dude, this is so well known already. Like, everybody does that. I do it too, in order to protect the attacker to do it first. But sadly, most of the time the attackers are way faster than the users because they don't know about it. And at the point where I figure out about that, it's already too late, right? So yeah, it's a wild world we live in. So the point of all of this is be more careful, god damn it. Don't sign transactions where you don't know what they do. Use different wallets for everything you do. Every airdrop, claim it with a different wallet, such that if one wallet is compromised, you don't lose all of your assets, just the ones you had in that particular wallet. You need to protect yourself a bit better, because it's way too easy for attackers to set the authority of your token account with token keg, because it doesn't support immutable owners. But I guess that kind of already concludes our video here today. I think I said everything that I wanted to say. Immutable owner, great extension. super underrated. Make all your token accounts immutable owner per default if you're using the new token program. And only not use that extension when you know that you're gonna move the token account around between programs and whatever. But yeah, that's a good additional check to have. Yes, it adds a little bit of compute, but I guess that's worth it. Hope you learned something today. How to stay safe from your token accounts being stolen. How to steal other token accounts. Yeah, we also learned that. But I hope that you use that for good and not for evil. Because it's such an annoying attack as well. It's the equivalent of bricking the wallet. It's bricking the ATA. And then the ATA is not usable anymore. Whatever goes in there belongs to the attacker. It's actually pretty much the same thing. That's why the attacks that brick wallets usually also steal a few token accounts, like set the authority of token accounts. I think good enough. I think I want to conclude. I mean, we could now look at like non-transferable tokens, which, you know, work pretty much the same way. It's just an extension. No, I'm fine with just focusing on immutable owners for this video. I think you got the whole idea of why it's useful and what the problem with the current situation is where we don't have that. And I hope with my Rayman arms, I hope that you enjoyed this video. If you did, give it a like. Make sure you are subscribed and watch those other videos. And then I'll see you in the next one. You can also let me know in the comments which token extension I should still be talking about. Yes, I still didn't talk about confidential transfers. It's on my list. I will do that eventually. It's just such a big topic. But we'll get there. See you then.